Okay, the next topic we discuss is line fitting. We know what is a line. Line would have certain components to it. It would have, if you're talking about a straight line, not a curved line, it would have certain slope and it would have a certain intercept with one of the axes. If we have any data, we can plot it, and if we can plot it, it would have a certain trend. It would be a very rudimentary graph that can explain how it is related to some other parameter. So for example, if we have independent variable in x and some variable which is depending on y in terms of f of x or g of x or whatever, and if we have certain data about for example, the heart rate or the maximum heartbeat per minute for a healthy being in a certain age, then we can plot it as well. For example, if we have age in years and corresponding heart rate for the individual, and the heart rate is in terms of beats per minute, and this beat per minute is the maximum which is tolerable for that individual at that particular age. If I use the data in this form for the age of 20, let's say the values for 20, 25, 30, 35, 40, 45, 50, and so on and so forth. I'm writing the data in terms of hypothetical one, the approximate ones. These are not medical data. For age when it is 35, let's say it is decreasing to 140. For 40, it is 144. For 45, it is 130. For 50, it is 125. We can plot all these based on certain values, and if we plot the age in terms of years, we would plot it like it's not starting from 0, of course, so it would start from 20 over here, 25, 30, 35, and so on and so forth. And similarly, we would have the beats per minute, since we have the data's minimum value and maximum value, so we can sketch it. We start from 125, 135, 155, and 165, and when we correlate them, so let's say the data is like this, and since the data is like this, we can draw a line which best fits this data in a way that it passes through the data in certain fashion that equal number of data points are above it and below it. So in that particular case, we say that this is the best fit for the data we have. Let's suppose we missed the data for years, 15 years of age kids, and it was 180. Of course, it would be for 15 over here, it would be here. So the data line, because we have now another value which is above it, so it is supposed to get a bit changed. So if I am carefully plotting it, it would be something like this. Because data here doesn't change, data over here changed, so it would go a bit up. Probably I've sketched it slightly more upwards, and in the case if the same data was not 180, instead it was let's say 120, so it would be something over here, so that this line would skew downwards a bit. So this is something which we do for finding the slope for the equation. Slope for the equation can be found out using this theta, whatever it is for here, and then finding tan of theta. That would be slope, and this point would be the intercept. So we can write a certain equation y equal to mx plus c as the equation for this particular straight line. And if we know the straight line, this can be called the linear fit of the data which we just obtained. So for another example, if we consider the year to price of a certain commodity in PKR, if we say the year 2000, the fee, let's say we say instead of fee per year in PKR for a certain program in 2000, let's say physics was in a certain university was let's suppose 20,000, and in 2005 it was 22,000. I'm very skeptical and very I'm imagining or estimating as I go along. 2010 it was something, in 2015 it was something, and then 20, and now in this year 2025. So let's say it is 22, and then it is 35, and then it changed again in 2050. It was, let's say, 50. In 2020 it changed again to maybe 80, and then now it is 120. So you can again sketch it. You use the year 2000 as 0. So every year in excess of that would be, this would be 0, this is 5, this is 10, this is 20, and this would be 20, this is 15, and this is 20, and this is 25. So if we plot it, it would be 0. And again, we are starting from 20,000. This is 120. So I would say, let's say this is 1, 2, 3. So I would mark them as 30, maybe 40. This would be 60, this would be 100, and this would be again another 41, 40. So if you sketch it, the data would be very low over here for earlier years, and then it would change, and it would change quite a bit afterwards. The data would be changing, but we would approximate it like this. This is a trend. Of course, this would be estimation. This would be a curve fit. The data actually changed more after 2015, so it would not be a straight line. So in that particular case, it would be a growth function of some sort, maybe exponential function, maybe another growth function, but it would not be linear function. So in that case, it is called a non-linear increase in the spread of the function. In that case, we would need to extrapolate and need to understand that this is not always a linear growth. It can be, for example, for bacteria, the growth is not linear. It does not follow linear growth, but for decay rate of isotopes of radioactive material, it is non it is it follows a certain trend. Okay, so for exercise, I would suggest you go through why we plot a certain function, consider examples from your daily life, and explore how a certain value changes over time, changes over different peoples, as per the, for example, if somebody is walking slowly, if he is sweating or heart rate is increasing at a certain way. Is it decreasing? Is it going up and down? So you can extrapolate, you can estimate how the two quantities are related to each other. And another example would be the population increase of a certain species. Another example could be the stress of a person, and the relationship with the blood pressure. And there could be uh, the number of students who passed out in a certain program over the years, if they have increased or decreased, and how the fuel economy of a car increases or decreases over time of use of the same actual fuel and same speed that person is moving the car. Anyway, wish you best of luck with your endeavors and your study and concentration on this subject.